fourth session, and this is the last session. And the name of the session is Decarbonization and Resilience. And we have 4 presentations also here. But unfortunately, our moderator, Gökhan, is not with us. And our discussant and moderator is Gökhan Kirkil. Hocam, Gökhan Hoca is the member of the CESD also. And Hocam, I stopped here and the screen is yours.
Welcome everyone again. So this is going to be an interesting session. So we have 4 contributors, 4 students will present their research. And we are going to start with the first one is our CESD student, Erkan, and he's going to present his research titled, Are the Decarbonization Targets of the European Green Deal Realistic?
Can you see the screen?
Yes,
okay.
Yes, sir.
Hello again. I did this research last semester for a course of Professor Ediger. The European Commission developed an extensive program called the European Green Deal. It launched in December 2019 and approved in 2020 by the European Parliament with the purpose of making Europe the first carbon neutral continent by 2050. At first glance, it could be seen as a policy against climate change, but it is a new and green growth strategy of the European Union. In my presentation, I will talk about EGD's targets, EU's energy regulations, EU's Commission figures, and I'll conclude. As we all know, the industrial age started after the Industrial Revolution, and toxic gases, carbon dioxide released in the atmosphere increased. We feel the negative impact of this on humans, like all living things in the ecosystem. Future generations will feel these threats more seriously, economically and socially. And the European Green Deal was created in response to these threats, actually. The President of the European Commission, Ursula von der Leyen, described the European Green Deal is our new growth strategy. It will help us cut emissions while creating jobs. And Franz Timmermans said, we propose a green and inclusive transition to help improve people's well-being and secure a healthy planet for generations to come. As can be seen from these definitions, the European Green Deal is an economic growth policy that regards to climate and environmental concerns. As can be seen, in order to realize this transformation, they created policies for different areas under 11 titles. And in the study, I focused on their decarbonization targets of European Green Deal. The European Green Deal divides into two steps, such as 2030 and 2050 targets. These 2030 targets are also serving as a cornerstone towards the zero carbon emission in 2050 targets. The European Commission has determined its targets for 2030 from the European Energy Directives in line with the Paris Agreement. There was a revision of the 2030 climate targets in the European Green Deal, and they augmented the greenhouse gas emissions reduction target for 2030 between to minimum 50% to maximum 55% compared with 1990 levels. But they didn't make any change for renewable energy and energy efficiency targets. In 2050 targets, the European Commission aims for a transition to a clean and circular economy. In this regard, it is emphasized to ensure that resources are used fairly and efficiently. Also, the EU adopted climate law in December 2020 to transform the 2050 climate neutral targets from a political challenge to a legal obligation, With this law, the political, economic, and legal regulations required to achieve the goal have been completed. Besides, the structure was arranged, which all sectors could act for the necessary change. So the EU will invest in eco-friendly technologies and support industry to innovate. One of the EGD's decarbonization goal is the transport sector. The transport sector is the most important area to fulfill the free movement of individuals, services, and goods, which is the most crucial part of the EU's integration process. It is also significant for economic and employment creation. So European Green Deal offers cleaner, cheaper, and healthier private and public transport and aims to decrease 90% emission in transportation sector because it is a quarter of the EU's greenhouse gas emissions. It will support decarbonization in the energy sector and ensure more energy efficiency on buildings and make cooperation with partners to boost global environmental standards. In this framework, increasing energy efficiency plays an important role in the decarbonization process because it saves energy in the demand and supply sector. The EU aims to reduce its energy consumption by 50% compared to 2005 level to achieve zero carbon emission, including buildings in 2050. Also, restoration of building biodiversity, which has started to mitigate as a result of feeling effects of anthropogenic climate change, and reducing pollution are included in the action plan of European Green Deal. European integration is based on politic and economic process. Member states cannot accomplish a coherent and uniform integration in energy due to their capacities, economic strengths, and international positions. Therefore, there are differences in the degree of ceding authority of union members at the European level. European tendencies about energy-related issues can be divided into three phases. In the first phase, energy supply security for Europe was significant. The European Coal and Steel Community was the first common energy policy and integration policy among the countries in 1951. The purpose of the CESD as an international organization to operate coal and steel reserves during the Cold War period with a supranational basis. After that, in 1957, the European Atomic Energy Community was established as an international organization after the Suez Canal crisis. The objectives of Euratom are to create a model market for nuclear power, to distribute electricity generated from nuclear power among member states of the community, and to sell the remaining energy to non-member countries. In the second phase, they focus on internal energy market, which is privatized and competitive since 1987. The Single European Act was signed in 1988. It created a European energy market under the title of an internal energy market and liberalized the European gas and electricity market. In order to be successful, it began the ETS emission trading system in 2003 and became a pioneer in the world. In the last phase, Lisbon Treaty entered into force in 2009. It was cornerstone for the European energy policy because it mainly focuses on competitiveness, security of supply, and sustainable development. Following this, the European Commission has set its energy targets and published the 2020 Energy Strategy in 2010, the 2050 Energy Roadmap in 2011, the 2030 Energy Strategy and Energy Security Strategy in 2014, and updated its previous energy targets. In 2015, the European Commission launched the Energy Union Strategy, which aims to create an energy union based on secure, competitive, affordable, and sustainable energy for EU consumers, such as households and businesses. There are 5 aspects of the energy union, and these are: first, security, solidarity, and trust; second, full integrated internal energy market. 3, energy efficiency. 4, climate action, decarbonization and economy, the decarbonization of the economy. 5, research, innovation, and competitiveness. The main reasons for the EU's struggle against the effect of climate change is its economic interests. For this reason, the Paris Climate Agreement, signed in 2016, is an international binding agreement which supports the EU's goals. And finally, as it's known, the European Green Deal launched in 2019 by the European Commission. The decarbonization targets in all climate agreements to which the EU is a party have been taken at the 1990 level. Figure 1 shows that the EU's carbon emission between 1990 and 2019 with targets for 2020, 2030, and 2050. In 1990, the carbon emission curves for the 28-member EU and 27-member EU respectively. It shows that the 28-member EU reduced carbon emission by 25.97% between 1990 and 2019. And the 27-member EU decreased its carbon emission by 23.65% during the same dates. So EU mitigated its carbon dioxide emission rates more than its 2020 targets in 2019. Also, EU should mitigate its carbon emission by additional 76% throughout the next 3 decades. Figure 2 illustrates the EU's carbon emission again, but this data has taken from BP, and according to BP data, 2008 was crucial for decarbonization because at that time there was a global economic crisis and industry all over the world slowed down. In other words, the global economic crisis turned into an opportunity for decarbonization goals and policies and gained a momentum for the future. Now we see the same dramatic decreasing ratio in 2020 due to the global COVID-19 pandemic. According to data, it is seen that carbon dioxide emission in EU decreased by 32% in 2020 compared to 1990 levels. In conclusion, in my opinion, the EU is aware that the devastating impact of climate change will adversely affect its economic development and competitiveness. Therefore, they have to realize a green energy transition. And moreover, the global pandemic, which started at the beginning of 2020, has created an opportunity for decarbonization targets such as 2008 global economic crisis. And in the light of these informations, previous regulations of the EU have even exceeded the targets and have been successful. Furthermore, in the future scenarios, it is expected that the 2030 and 2050 targets, like the previous one, will become true with EU's new regulation. Thank you.
Thank you very much, Erkan, for this very good presentation. It's also a timely topic because, as we know, the Turkish Parliament ratified the Paris Agreement 2 days ago. So there are lots of news in the TV channels and other newspapers about this. So are there any questions from the audience to Erkan? I have one question, Erkan. We have lots of targets and in different sectors like farming and industry, residential, energy, and other sectors. And do you think this deal is like very good at monitoring things, and if things don't go like as they expected, is there penalty mechanisms, or how do you think they will monitor and evaluate the progress until 2050?
I think this is important because they are pioneer in the world for green transition. Of course, they have some problematic files, but there was a theory, I guess, about it, neighbor following theory. I'm not sure the exact name, but for example, Turkey, countries look at their neighbors and what they are doing. They are implement their policies, and the European Union don't have this chance because they are the pioneer. Also, there was a report by Greenpeace. I don't real the exact name, exact amount, but they said 5 big major fossil energy company was lobbying the EU parliamentarians before the Green Deal launched, and they said the drafts were much more strong than the final paper. And 2050 being net zero target in 2050 is the latest date for Europe's economy. So I think they can be realize this green transition because it is the latest date for them.
Okay, they thought that the past progress was very successful, so they can continue with the same in the coming years. So there's a question in the chat from Mutlu. Is there any list of budgets for the target of decarbonization of the countries signed the agreements, and also Turkey?
I don't have right now, but I can show and find.
Yeah, I think Turkey. I mean, there are like national climate emissions plans. I think the countries signed the agreement, Paris Agreement. They immediately start preparing that, and that's also coming for Turkey. We need to also prepare that kind of inventory and what kind of sectors we have and how much we're going to, how much we are currently emitting and what's going to be that in the future. So we need to come up with the numbers and targets for the future. So the next step after the signing the agreement is actually preparing that national plans. So hopefully in Turkey we will also start preparing those plans. But if there are any other questions, thank you, Erkan, for your great presentation, and we can move to the next speaker. I think there are no other questions. So Begüm Begüm Ünlü is our next speaker. She is also one of our students in the Sustainable Energy and Development program, master's program. She was also one of my students, and she successfully defended her thesis a couple months ago, and it was like after corrections and everything. She has graduated actually successfully. Her thesis and I think her topic today will be decarbonization application in the industry sector. So this is one of the again critical issues because industry sector is not easy to follow these new transition plans. So her thesis was also very timely topic. So the floor is yours, Begüm. So you can start your presentation.
Hello everyone, can you hear me clearly?
It's a little bit low, I guess, if you can.
Okay, I will try my headphone.
We can't hear you. Maybe you need to adjust the source of your microphone and speaker at the lower left corner of the Zoom settings. Yok.
No, we cannot.
Şu an nasıl peki? Yani çok mu kötü? Daha mı iyi?
It's better.
Okay.
Gökhan Hoca, we cannot hear you.
Biraz daha yüksek sesle konuşursan, bilgisayara yaklaşırsan olacak Begüm sanki.
Okay. I think it's fine now.
I think it's fine. Right?
Okay. I am sharing my screen now. Hello to everyone. Yes, is it okay?
Yes, okay.
Ekranı tam göremediğim için şey yapamadım.
Begüm, şu hemen sağ altta böyle kupa gibi bir şey var ya. Hı.
Okay, I just graduated from Energy and Sustainable Development Master Program from Kadir University. My thesis topic was about decarbonization potentials in the Turkish energy intensive industries. So I focused decarbonization and implementation in industry. And today I will make a presentation about decarbonization applications in the industry sector. I would like to start my presentation by talking about the outlines. First of all, in the introduction, I will talk about why I choose this topic. Later, the definition of decarbonization and why decarbonization and decarbonizing the industry is important issues will explain. And in the last section, I will describe decarbonization applications which were classified in 4 categories. Since my undergraduate is industrial design, I learned about the industry, including the project ideas and my internships, and met with concepts such as sustainability and circular economy with my first work experience. Working to reduce environmental impacts in the industry became my focus over time. And I started my master's degree in energy and sustainable development. I aimed for my thesis firstly to be close to the circular economy, but along with my research, I discovered the topic of decarbonization. Especially information from studies prepared around the world excited me. In addition to the limited number of studies in this field in Turkey, the narrow scope of these studies made me realize that there is a deficiency in this field. So I decided to write with hoping of providing an inspiration to energy-intensive industries and related government organizations. What is decarbonization? Actually, it's roughly, we can say, doing more with less. In Nakichenovic's words, it's a definition of decarbonization. And we can also say decarbonization is doing the same work with higher energy efficiency and material efficiency, and emitting less carbon per unit of energy consumed. Reducing energy, material or carbon density, and reducing carbon emissions through decreasing fuel, energy or material consumption. Decarbonization is an important issue because we are faced with climate crisis in globally, and we have to do something against it. Since the past, various meetings, agreements have been tried to be made in order to adopt common goals around the world. And with each passing year, international organizations are increasing their pressure on countries to reduce their environmental impact and carbon emissions. In this process, it is important to prevent the economy from being negatively affected. Ensuring decarbonization in industries where the economy is closely related, especially in Turkey, gives a change to countries for progress in line with these global targets. Ensuring decarbonization in the industry is an important issue because the industry has a large share in carbon emissions. In the graph from IEA data, we can see the distribution of carbon emissions by sectors in 2018. The industry sector has a total share of 18% and ranked the third line. Also, when we can compare, achieving to reduce emissions in the industry sector is more harder than all of the other sectors. This shows that we need more focusing in decarbonizing in the industry sector. However, achieving to reduce emissions in the industry sector is more harder than other sectors because carbon emissions of energy industries, transportation, or households could significantly reduce by transition to renewable energy sources and electrification. Of course, this transition will not be easy, but I just want to point out that more efforts should be made to reduce emissions at similar rates in industry sector because achieving to reducing emission in industry it's more harder because the industry sector has numerous subsectors and facilities. In order to ensure decarbonization, solutions suitable for each production processes, equipment and sectors must be developed and applied. In the last part, I will summarize the decarbonization applications in industry sector. I reached the decarbonization implementations from many studies, and I have classified them according to which stage they are used. As a result of production and consumption in the industry, greenhouse gases, which contains intensively carbon dioxide, are released into the air. If we directly deal with carbon dioxide released into the air without making any changes in the production processes, we can use carbon capture storage or carbon capture and utilization technologies. But these technologies couldn't be applied right now because they're not commercialized yet. And the source of carbon dioxide released into the air is the types of energy used. It is also possible to reduce carbon emissions by switching to those with lower carbon content in this energy source. As you reduce the carbon intensity of the energy source, it is also possible to reduce linearly the carbon emission caused by energy consumption. For example, if coal is used in furnaces, switching to natural gas could be reduced carbon emissions, or changing the devices to use low carbon electricity could reduce more carbon emissions. And the energy is used by the equipment. The changing or improving the devices for increasing energy efficiency could reduce carbon emissions too. Because when you increase the energy efficiency, you will consume less energy, so related carbon emissions will be reduced. So improving equipment to best available technologies, to adapting to use electricity or reuse the output of these equipment such as gas, heat or steam with combined heat and power technologies could reduce carbon emissions. All these production processes are carried out to finally produce a product. So increasing the efficiency of the materials used for the product will also indirectly reduce carbon emissions. The solutions that increase material efficiency could be achieved by producing long-lasting and modular products, providing consumer behavioral change and increasing the recycling rate, producing the same product with less material with technologies such as 3D printing, using materials with lower carbon density with material substitution, for example, using aluminum instead of iron, and taking initiatives to reduce consumption and production with circular economy, for example, focusing on reduced consumption by improving sharing or product as service systems or increasing industrial symbiosis. And my presentation is final here. Thank you for listening to me. If you have any questions, I can say.
Thank you very much, Begüm, for your presentation. Yeah, we can move to the next presenter, Onur Akkaya. He's contributing to our conference from Middle East Technical University. And I think it's another decarbonization talk, also related with the Paris Climate Agreement goals, and especially focusing on carbon capture methods. Onur, the floor is yours.
Thank you, Hocam. Let me share my screen. And hopefully you can see the screen and hear me at the same time, not without a problem.
Yes, we can see.
Okay, hello everyone. I'm Onur Akkaya from Middle East Technical University. I'm here to present my work that has a title of Investigating the Efficiency of Carbon Capture, Utilization and Storage Methods to Mitigate Climate Change. This is the outline of today's presentation. At the beginning of the presentation, in the introduction part, I will be talking about the carbon dioxide emissions and the price comparison between the fossil fuels and renewable energy sources. Secondly, I will explain basic concepts about the carbon capture, storage, and utilization. In the third part of the presentation, I will explain possible risks related to carbon capture, storage, and utilization projects. In the fourth part, applications of the CCSU projects in the world and in the Turkey will be explained by using 2 case studies. Finally, I will try to conclude my presentation. So let's begin with the carbon dioxide and the climate change. As we all know that the greenhouse gas emissions, especially carbon dioxide emissions, are the main driver of the climate change. When we check the global carbon dioxide concentration historically, we have some upsides and downsides. High carbon dioxide concentration of the atmosphere are related with the warm periods, and the warm periods are related with the high atmospheric carbon dioxide concentration, and similarly low concentration means colder periods. Historically, 300 carbon dioxide particles per million was the peak. However, we have a continuous increase in the last century, and now the carbon dioxide concentration of the atmosphere is more than 400 particles per million. When we check the historical and the projected carbon dioxide emissions, we can see that the CO2 emissions will continue to increase. Therefore, the atmospheric concentration of the carbon dioxide, as you can see here in the green line, the projected carbon dioxide emission is going up and up. When we check the carbon emissions, we can see that the carbon emissions from the energy use are the largest source of the greenhouse gas emissions. nearly 60% of all emissions are related with the energy, and remaining 40% is non-energy emissions. Therefore, it's vital to investigate energy-related emissions in more details. So when we check the global primary energy consumption, it's continuously increasing and can expect to increase more in the following years. This means that we will need more energy and we will emit more carbon dioxide. If we check the shares of the primary energy, we can see that the fossil fuels are dominating in here. Oil is the oil representing with the yellow line has the biggest share and is the primary energy, and followed by the other fossil fuels, coal and natural gas. Summation of all these fossil fuels is around 85%. Renewable energy here is represented with the green line, is only 5%, and the increase in the renewable energy only happened in the last 10 years, basically after 2010. When we check the global primary energy projection in the rapid decrease scenario, which was defined by the International Energy Agency, percentage of the renewables in the total can be reached to 40%, here around 40%. However, summation of the fossil fuels are still the remaining 60%, and it's still very high and higher than the renewable energy. So finally, when we conduct a price comparison between the solar energy and the oil and gas, we can see that when the oil price is equal to $13.7 per barrel, solar energy price should be less than $0.02 per kilowatt hour. Otherwise, the oil is very cheap. Similarly, when the price of the 1,000 meter cube natural gas is $110, solar energy should be cheaper than $0.02 per kilowatt hour. Otherwise, people will have a tendency to use fossil fuels instead of the renewable energy due to the economical concerns. So, usage of the fossil fuels in the energy sector is the main driver of the climate change, and the fossil fuels usage will be more than the usage of the renewable energy in the following years. It can also be cheaper than using the renewable energy. Therefore, it's possible to expect high carbon dioxide concentrations as well as high greenhouse gas emissions. Now, let's move to the second part and let me talk about the carbon capture methods. Best possible way to capture carbon is from a point source. Refineries, cement and steel factories are considered as high emitters and regarded as and considered as the point emitters. Basically, carbon capture units are installed in the chimneys of these point emitters, and once the capturing is started, they capture nearly 90 to 95% of the carbon dioxide from the flue gas. Direct air capture is a possibility. It's possible to directly capture the carbon dioxide from the air that we everyday breathe in. However, it's not very feasible. In carbon capture and storage, in CCS, once the carbon dioxide is captured from the emitter, it's transferred to the geological storage area and it is injected into the geological storage unit. Oil and gas reservoirs, natural traps are possible geological units for the storage. It is desired to permanently store the carbon dioxide in these traps. In carbon capture, storage and utilization, in CCSU, the captured carbon dioxide is injected into the reservoirs, active oil and gas reservoirs, to produce more hydrocarbons. And once the production is completed, CO2 is stored in there permanently. So in the production phase, CO2 is injected from one end, and in the production end, CO2 plus hydrocarbons are produced from the other end. Once the produced carbon dioxide obtained in the surface, it's separated and injected back into the reservoir. So basically, there's a recycling process. In carbon capture and utilization method in CCU, captured carbon used as a raw material for the production of the other goods. It's possible to use it for the carbon natural fuels, chemical synthesis, carbon mineralization, and etc. CCU methods are considered as the carbon neutral methods, as they did not remove any carbon from the atmosphere, but changed the form of the carbon dioxide. When we check the historical carbon dioxide capture capacity, we can see that there's a continuous increase in the installed capacity. This technology is relatively new and becomes more popular in the last years. Gas processing is the main area. However, new areas are also introduced for the carbon capturing. As it is a new technology, it involves some possible risks, and this brings me the third part of the presentation, which is the possible risk about the carbon capture and storage methods. This figure shows the typical hydrocarbon reservoir, and here we have a cap rock that isolates the oil and gas reservoir from the remaining of the geology. Below the cap rock, there's a hydrocarbons, and below that, at the bottom, we have water zone. Generally, carbon dioxide is injected into the hydrocarbon zone of the reservoir. Injecting carbon dioxide at the regions where we don't have cap rock or about cap rock can cause problems because CO2 is no longer trapped or isolated and can freely move to the surface or other geological units, and we just missed the main objective in that case. Also, injecting carbon dioxide into the water zone is problematic because groundwater zones are very complicated and very complex, so they have some connections with the oceans, nearby rivers or seas, and they can reach to the surface as it happened in the Lake Nyos disaster. A limiting eruption happened, meaning that carbon dioxide at the bottom of the lake just reached to the surface in a very short time. 0.1 to 0.3 million tons of carbon dioxide released immediately, very suddenly, in a very short period of time, and overall 1.6 million tons of carbon dioxide reached from the bottom and released in the surface. And this accident or disaster caused the death of 1,800 people, nearly 1,800 people, which is a very high number, I believe. Now let me talk about the field studies of the carbon capture and storage. So in applications in the world, there are 37 large-scale CCS facilities, and 21 of them captures more than 30 millions of the CO2 per year, and most of them are in the United States. Project Petronova is one of these projects. In this project, carbon dioxide from the Petronova coal refineries Unit 8 is captured and transported into the West Ranch oil field for the improving oil production from that reservoir. It's a financially huge project. This project received $0.2 billion grant from the government and another 0.25 or $250 million loans from the banks. Financing of this project considered to be done with the additional oil recovery resulting from the carbon dioxide injection. Approximately 4,000 tons of carbon dioxide planned to capture daily, meaning that 1.4 to 1.6 million tons in a year. Due to the high distance between the emitter, the point emitter, the coal refinery, and oil reservoir, a pipeline is constructed for the transportation of the carbon dioxide. Oil production was increased from 300 barrels to 15,000 barrels per day. So 50-fold increase happened, which is a huge number. However, due to the decrease in the oil price, the project did not provide required income. Expected oil price was $100 per barrel. However, oil price did not reach that value due to the crash happened in the beginning of the 2010s. This figure shows the carbon dioxide emission intensity, and we can see that once the carbon capture system begins to operating, the emission intensity decreased significantly, so the system was overall very efficient. Now let me explain the applications in Turkey in an oil field. This case is from Turkey. As you can see, we have some points are marked in the map. These points are the locations and distributions of the main carbon dioxide emitters. The blue squares are here represent the cement factories. The red circles are the thermal power plants. The green triangles for the refineries, and the black polygons are representing the carbon sinks, basically the places where we can store the carbon dioxide. Here, this one is Batman. There's here we have in Batman we have the biggest oil field of the country, Batraman oil field, and we have a refinery nearby. So let me provide some information about the Batraman oil field. This is the biggest one in the country. The estimated resource of the oil field is around 1.85 billion barrels. After the discovery in 1960, the production started to decrease, and carbon dioxide injection was considered and applied, and it increased the carbon oil production. However, the source of the carbon dioxide was a nearby field, but it's possible to replace this source with the emitter with the Batman refinery of the Tüpraş. The distance between the Batman refinery and the oil field is around 8 kilometers, so the applicability is very highly. The capacity of the Batman oil refinery is around 1.4 million barrels per day, and it's a rule of thumb as 440 kilograms of carbon dioxide emission for refining a barrel of oil, and leads to 6.2 million tons of carbon dioxide per year. In 30 years, 11 million tons of carbon dioxide was injected, and in the following 10 years, expected total injection volume is 4 million. So supply from the refinery is not a problem for the injection, and it's possible to inject captured carbon dioxide into different reservoirs if it's possible. When we have considered the emissions of Turkey and the mitigation scenario in 2030, Turkey needs to reduce the emissions by 250 million tons, which is nearly 21% of the all emissions. In 40 years, 15 million tons of carbon dioxide is injected into the Batıraman oil field, meaning that nearly 6% of this 250 million tons is injected into the reservoir. So this could be one way to help Turkey to mitigate its emissions. Let me conclude my presentation. Here, the atmospheric carbon dioxide concentration increased significantly in the last century due to the increase in the greenhouse gas emissions. Fossil fuels in the energy sector is the main reasons of the greenhouse gas emissions. In the following years, fossil fuels will still be the main energy source. And direct decrease method is carbon capture methods, and it's one way to limit the increase in the atmospheric carbon dioxide concentration. However, it's not a sole solution, and it cannot mitigate the climate change by itself. It could be a helpful tool to reach the goals defined and to mitigate the climate change. Thank you for your attention. If you have any questions, I would like to answer them.
Thank you, Onur, for your presentation. Any questions from the audience?
Yeah, I'd like to ask a question, Onur. Onur, which department are you from?
Hocam, I have two master's degree. One is from the petroleum engineering, and the other one is from the earth system science. Both of them from METÜ.
You've completed your master's study? Now, are you working somewhere now?
Yes. So,
okay.
I'm working at the METÜ as a research assistant in the petroleum engineering department.
Yeah, okay. You mentioned about Lake Nyos. Is that the right, correct pronunciation? I don't know. A big accident, the gas coming out of the lake and more than 1,000 people killed?
Yes.
Why? What was the reason for that? Yeah, I mean, was there a CCS technology underneath?
No, there was no CCS technology, but I would like to show that if the CCS technology is not applied or installed properly or designed properly, it can reach to the surface if you inject the carbon dioxide in wrong zones, basically.
What was the problem there? Why did this thing happen there?
I'm really not sure about that one, because it's a limnic eruption and it's a natural event, basically. The people shouldn't live according to that region, near to that region. That was the main reason, actually. But because of the tectonic activities, most probably the carbon dioxide from the bottom of the lake reached to the surface.
Exactly. That must be the only reason. You know, there might be some faults or cracks happened in the crust. So all of a sudden, all the gas came out of the surface. And as a matter of fact, in the world, there are a lot of gases coming out of the surface. In Azerbaijan, for example, there is an area called Yanardash. The gas is coming out of there in Olympus Mountain and etc. So when we're talking about risks, we have to talk about tectonic activities possibly first, right?
Yes.
Okay. And the other thing is, you mentioned about EOR techniques, enhanced oil recovery techniques.
Yes.
You know, the project that we are applying in the Southeast Anatolia is we are producing carbon dioxide and we are just injecting back it into the reservoir to push the oil, because the oil is very heavy there. They don't move. Mm-hmm. So, but you're suggesting us to use carbon dioxide from Batman refinery, for example, used it as an EOR technique. But do you have any, well, this is not a storage technique. This is another technique. And do you have any idea about if those gases are storing there or coming out of the surface again?
Since the production is happening there, like as I know that there's no problem about storage there. Once the production is completed, you can safely store there and close the wells, cement them, and carbon dioxide can store there.
No problem at all, huh? Okay.
Yes, as I know that, but
okay, in your
course,
map, you know, you show two possible areas. One is Southeast Anatolia for Turkey.
Yes.
And the other one is around Manisa region, or?
Yes, it's a geothermal field. It's Kızıldere geothermal field.
So how can we, is there a reservoir there that we can put the gas back into the reservoir?
Geothermal reservoir. There's one huge geothermal reservoir. It's one of the biggest in Europe.
Yeah, I know that, but can we store carbon dioxide into the depleted or not depleted in that case, into the geothermal reservoirs?
There are some applications in the world, and there's a research group in our department that are working about that project. They are investigating injection of the carbon dioxide in that field, and they are still investigating it. So it's possibility.
Is there any example for such a thing in the world?
Yes, I believe in New Zealand there was one minor example, but the field was not very big and the capacity and injected volumes were not significant.
Yeah, okay.
It may be also, that maybe also they are injecting carbon dioxide to maintain the pressure for the long term, maybe. That might be also another reason.
Yes,
not maybe
of course.
For the actual storage application, but also to maintain the pressure for the long run so that they can.
Exactly, yeah, that's the purpose there. And as far as I know, there's no commercially operating CCS technology in the world. Am I wrong?
Well, at this right now, as I know, there are some CCS technologies are in the United States.
But they are all in the plant facilities. I mean, just to test whether it works or not. It's not commercially operated. It's a pilot facilities, is it?
Yeah, this technology is very new and not very commonly used everywhere else. Some field studies, some projects in the United States, but their capacity is huge, so I decided to mention about them.
Okay, thank you. Thank you.
Thank you. I think in the long run, also the technology cost should decrease to make it more practical and applicable.
Yeah, the costs are very problem in that.
Yeah, one of the carbon mitigating solution. Thank you. And if there are no any other questions, we can move to the last talk of this session. Thank you again, Onur.
You're welcome.
Presentation. So the last talk will be given by again one of our CESD students, Fatih Avcı. His study with Professor Gökhan is titled "Energy Optimization in the Case of Emergency: Case Study for Thrace Basin." So it's an interesting case for the Thrace region. So the floor is yours.
Thank you, Gökhan. Can you see my screen?
Mm-hmm. Yes. I think you need to put it in slideshow mode. Yeah.
Okay. So it's okay now.
Mm-hmm. Sure.
Okay. Hello, dear audience. I'm Fatih. I am a PhD student in industrial engineering in Kadir University, and I'm working with Volkan about the energy resilience topic. We are focusing on climate change and unexpected disturbances effects on the power and gas systems, especially. Today I will present what is resilience and optimum consumption in a possible scenario analysis for the Thrace Basin. So I will start with the definition of resilience. We can define resilience as a capacity of recovery from a disturbance. As you can see in the graph, it is the jump back to the previous level before the disruption. In ideal systems, the recovery time should be minimum and reach the full recovery point, as you see in the graph. In our study, I will talk about, we focused on the critical energy infrastructures. The disturbances can be internal or external. In our study, we analyzed the two different external cases. One is expected Istanbul earthquake, and another one is the possible terror attacks to the especially natural gas pipelines. You can see the supply chain of both gas and power systems. In this slide, you can see the basic natural gas scheme of the Thrace Basin. The main gas inlet is from Turk Stream on the right pipeline, on the right side, on the Kirkil side. All pipeline is not active anymore in the Bulgarian border. There are gas extractions in Thrace Basin, which are like blue points, and mainly in Kirkil and Tekirdağ, but they are so small amounts. We also showed the LNG injection point in Marmara Ereğlisi and the storage area in the Silivri region with S and the LNG on the lower side of the slide. In here, you can see the detailed information about the infrastructure and inputs and the consumptions. We analyzed the consumption in December 2020. You can see the main gas is coming from the Turk Stream, about 48 million meter cube as a daily average. So you can see the consumption in below table. The main consumer is households, around 50% of the consumption. Because of it is winter and it's December, and the main purpose is heating, of course. And this is, in this slide, you can see the basic power generation points and the transmission lines. I should simplify this map, but don't have enough time to sketch this again like the gas one, so sorry about this. Here you can see the detailed information about the existing power plants capacities and the power generation from the cities, especially. As a first approach, the generated power is not enough for the consumption for the Thrace Basin. So the region can be fed from the other power plants from Anatolia, especially. There are two notes from this slide. The 83% of the generated power was coming from the natural gas fired power plants, and the 45% of the total generation is coming from Istanbul-based power plants like Ambarlı and Esenyurt power plants. Both of them are operating with natural gas, and so the natural gas supply is really critical for Istanbul. As I mentioned before, we have two scenarios: earthquake and terror attack. The first one, earthquake hit the compressor stations in Ambarlı and Esenyurt region. It means no gas supply from the Turk Stream to the Istanbul region. Only storage system will feed the Istanbul from the Silivri area, coming from the Silivri area. The second one is terror attack happened in the main pipeline before Tekirdağ region. So the gas will come only from the storage and LNG system. Sorry. As all we know, there is an expectation of 7+ magnitude earthquake in Istanbul, and you can see the fault lines and the main energy infrastructure are located in the red area on the map on the left side. So what about our scenario? In our scenario, there is a disruption in the entrance of Istanbul, in Ambarlı and Esenyurt compressor station. So it means gas is only provided from Silivri storage area. it means there is a less gas on the pipelines, and gas-fired power plants cannot be operated in Istanbul. Because of winter times, gas should be transferred to households in terms of priority, because for the heating purpose. So the maximum daily injection of the storage facility is 25 million meter cube per day in the Silivri, and the households consumes around 22 million. After households, gas will transport to the service sector because its share in GDP is more than industry for Istanbul. This is the different case, because in normally in another region like Tekirdağ or Bursa, the industry have a bigger share than the service sector, but Istanbul, it's different. So in second scenario, we analyzed a possible case for the terror attack in the main pipeline. So you can see the historical pipeline terror attacks in Turkey. Unfortunately, we don't have the recent data from the BOTAŞ. The last data is from 2013. Yes, in our scenario, we have an attack on the main pipeline before Tekirdağ. So our constraints will be like this. So gas should be supplied to households in Istanbul and Tekirdağ, and gas power plants in Istanbul should be stopped, and the power and gas balances should be calculated for these constraints. And also I will show the economical losses of the two cities. You can see we can only feed the region with LNG and storage area. These two cities need 23 million gas for households, and 4 million meter cube gas for industry, and 4.8 million for service sector. So for both two cities, we can supply gas from both LNG and storage if the both are available. If there is not an injecting LNG ship on the LNG terminal, the supply will be provided only from storage. So in this case, gas will transfer to only household consumptions. So for these cases, the authorities should solve the problem in terms of their priorities. So this is the brief of the both scenario in the big picture. So scenario 1 is on the right side. It's mainly for Istanbul, and scenario 2 is for Istanbul and Tekirdağ. As a final, in scenario 1, the storage will feed the system, and the 22 million meter cube will be provided to the households in winter times without any interruption. So remaining gas will be directed to service sector, as I mentioned, because it generates more GDP than industry for Istanbul. Gas is available on the Kırklareli site, and the gas power plants can be in operation on the Kırklareli region. So we don't have any electricity problem we are expecting like this. If there is no problem on the electricity transmission lines. And economical loss for Istanbul will be around 850,000 lira per day. And damaged stations, pipelines should be recovered as soon as possible, because if the service sector and the industry, if they're not operating in each day, they will lose 850,000 lira per day for the country economics. In the scenario 2, if the gas is only coming from the storage, gas is distributed to households consumer for Istanbul and Tekirdağ. There will be a small amount gas for service sector, and GDP loss from both industry and service sector is more than 2 million lira per day in this case. So as I mentioned, the problem and this kind of problem should be solved as soon as possible again. And if storage and LNG option is both available, so there is not a big problem. Gas can be supplied for all consumers, but of course not for the power plants. Gas power plants can shift to fuel oil operation if needed. But right now, I think we don't need these kind of things, because we have energy surplus and we have some other power plants in the Anatolia and other region. So we can take our electricity from that part of the country. So transmission lines and other power infrastructures should be optimized and capable for transferring power from outside to the Thrace Basin in this case. As a conclusion, so power and gas transmission constraints would impact the long-term planning schedule of the energy systems. Installation of new storage systems or alternative compressor stations and implementation of the fuel switching capabilities are effective strategies for more resilient energy sector. In this way, country can reduce their economical losses and unexpected losses of industries and service sectors, I mean. For better and precise calculations, energy resilience metrics should be measured for baselines, especially. These metrics should allow the relevant boundaries for possible scenarios. And research and development studies should be made for advanced decision support to authorities like BOTAŞ and these kind of authorities. Energy is interdisciplinary, as we know, interdisciplinary branch, and the success will come with the multidisciplinary team. I'm basically mechanical engineering, but working with other disciplines. So in energy sector, it should be like this. So this is end of my presentation. So if you have any question, I'm happy to answer. Thank you.
Thank you, Fatih, for your presentation. It's actually a very good talk about resilience related to the topic of this session. And are there any questions from the audience? If not, I have a small question, Fatih. So when you say we should install more storage facilities and compression stations, so your research or your thesis, is it going to answer how many of them or what capacity should be installed where, or is it part, are you going to answer those questions in your thesis?
Yeah, we can answer like this. If there is not an LNG on that time, for instance, where when a let me say explosion happens, if there is not an LNG ship on our LNG terminal, we can need another capacity. But if I'm not wrong, there is an expansion of the capacity of the Silivri storage area. So I think after that expansion, it will solve the problem. But we can calculate the how much gas we need or how much the extra capacity it should be. We can calculate this.
Mm-hmm. Okay. Any other questions? All right, we are very late in the afternoon, also 15 minutes late in this session. But I think all the presentations were great. I would like to thank all the presenters, and there were very good discussions also at the end of the presentations. I think it was a very fruitful session, and thank you also the listeners and contributors. So thank you very much, and we are closing this session.
Thank you, Gökhan Hocam. Gökhan Hocam, is closing remarks. Can you say something?
Yeah, I'd like to say a couple of words about the conference. I'm really enjoyed this conference a lot. You know, the students are getting experiences, and this is really a very unique conference. It is organized completely by students, and the presenters are all students. But however, you know, since we thought that only the graduate students will give presentations in this conference, we also had some undergraduate students that made me very happy. There were 2 or 3 papers given by the undergraduate students. So maybe we have to change the name and include, just delete the graduates, and all students can give a presentation here. I think it will be a very good experience for you. You know, giving a good presentation depends only on making practice. There is no strict rule of giving a good presentation. You have to make practice. You have to give conferences and papers in different gatherings so that you'll see your mistakes there and the other people's mistake, and you correct it, and you get improved after every conferences or papers. I really would like you to encourage your friends, your students, your colleagues to give papers in this conference. This is a very good chance for all of the students to improve their practice of giving papers. You know, it was the 4th time. So we have started this conference 5 years ago, and we couldn't do one year in the middle. And I hope we will repeat the same conference in next October. So we would like to see you all in October 2022. Last list, you know, I have to make some acknowledgements, especially to the organizing committee, to the technical committee, and to the discussants and the moderators. And last but not least, all the presenters. I really enjoyed listening those scientific work here, and I encourage them to repeat giving papers in our conference or in other conferences too. But there are 2 people who deserves special thanks. One of them is Salihe. Thank you, Salihe, for organizing, for spending so much time, sacrificing your master's thesis studies.
Thank you so much, sir.
Another person is Hazal. Gerçekten Hazal is always doing a great job in any kinds of events that we organize. Maybe I may make one announcement. So we are just organizing a new event series on the Green Deal, and we are starting the first session on Tuesday at 6 o'clock with a very distinguished person about the Green Deal of European Green Deal. She is really an expert. So we all are waiting for you to be with us there. Thank you again for all of you guys. Thanks.
Thanks a lot. Have a nice day, everyone.
Ahmet Hocam, can you say something about conference?
Actually, I would like to thank again Salihe, Hazal, and other organizing committee and Volkan Hoca for this successful event. I mean, when we spoke at the morning, we have talked the sustainability, the importance of sustainability in such conferences, because I mean, this kind of events start 1 year, then stopped again. Maybe if it is lucky, you can do it 2nd year, but then stop. But this is 5th year almost, and we are doing this 4th conferences. Hopefully, we will see another one next week, next year, and then we will see this conference become bigger and larger, you know, throughout Turkey. And this is a fantastic event, I believe. I mean, for students, organized by students and master students, some undergraduate students had a good opportunity to present their work. And I have some notes. I mean, it is a good news. I mean, as engineers, people from engineering background, Volkan Hoca and Gökhan Hoca may know better, we all have always been working on the quantitative aspects of the energy. I mean, how we plan the future, how we use the resources. But I have seen some presentations going to some different direction, like, you know, the relationship with the environment, the relationship between social science and energy, the data usage and energy, the technology used and energy, renewables, resource planning and usage. such aspects, such dimensions of the energy industry and literature became very important, are good news for us. It means that, I mean, in Turkey, there are some new generation of scientists working on this kind of issues, and we will be able to plan our energy better in the future. I congratulate all the participants and presenters for their successful work, and I hope you will be better in your future careers. Thank you very much, Salih.
Thank you so much, Ahmet Hocam. Okay, we hope that we can see the next year.